Hello, so today we are going to do this problem, part of Leetcode May challenge. So the problem says we want to remove all adjacent duplicates in strings. So what that means basically is that we get a string s and an integer k, and what we want to do is do a k duplicate removal, which basically means finding equal letters, k equal letters, and removing them each time, repeatedly removing them essentially. So let's take a look at an example to understand this. So here we don't have any, but let's look at this example. This one is better. So k equal to 3, which means we want to remove every 3 duplicate equal consecutive letters. So for example, we can do it in any order we want, but here we can remove EE and then remove 3 C's here. But we also have, once we remove these 3 C's, we have 3 B's here that become consecutive, so we can remove these. And once we do that, we have this D, and this D that become consecutive, so we remove them as well. And now we are left with just 2 A's, and so we return those. Okay, so let's see how we can solve this problem. So I took the second example here, and I just drew it in a way where I'm hoping it's easier to see a solution this way. So D first, I'm just writing it from the bottom up, but this is the same word. And so what the problem asks us to do is basically remove the consecutive ones first. So we remove these 2 E's, right? Let's say we go in order. This is the simplest thing we need to do. And then now we have 2 D's. Our K is equal to 3. So we leave these alone. 2 B's, fine, but we find 3 C's here, right? So we delete these. But notice, once we do that, now we have 2 B's here, and then this B here. So 3 B's, okay? But before it was 2 B's, and so we didn't remove them because it was only 2. But now we can because it's 3. So the main observation here is once we remove consecutive letters, consecutive duplicate letters, we may have a chance to have a new set of consecutive letters. It's similar to Tetris, where if you have, let's say, 3 things of the same color, right? Let's say maybe here another blue here, so you have 3 blues, and so they get removed, right? Now you have 3 consecutive reds, and so these 2 also get removed, right? So that's the same concept here. So what we need to do is be able to identify this, okay? And to be able to identify that, what do we need? We just need to be able to pick how many consecutive B's we have here, right? So if we had somehow a count here of how many B's, we can tell, okay, we have an additional B here, so 1 plus 2 is equal to K, which means we can just remove these. And removing would be really easy because it would be just popping this here from the stack, popping B2 from the stack. And so the main idea here is, okay, let's just keep a track of a stack because we can easily pop as we are traversing the string. And we can easily take the top one and add to it, for example, in the case of a new B found here. Okay, so that's our main idea. So what we'll be doing here is, let's take an example. So this would be our stack, and what we'll be adding to the stack is the letter, and then the consecutive occurrences, the count of the consecutive occurrences. So here we find a D, right, first, so count only 1, and then we found 1 E here, right, and so we add it because it's not, if we found a D, then we would just update this count to be 2, because this counts the consecutive occurrences. And so here we have E1, but then we found another E here, so we move our pointer, and we found another E here, and so we have, so we add it, right, because the top one is E already, we advance again, we have another E, so this becomes 3. And then when we reach a new D, well, we already actually when we reach K, so now we are equal to K. So that means we can pop, because that's what removing is. So we can pop and remove these. Okay, so this is popping. Now we are at D, and so D exists here at the top, and so we increment the counter. So we increment only if it's the top one. So now we increment our counter, it's 2. And then we have B. B doesn't exist already, so we add it to our stack. Count 1. And then we found another B, so we update our stack count 2. Now we have C, it's a new value, it's not the one at the top of the stack, so we add it with value 1. And then another C, so value 2, and then another C, so the value now is 3. And now we are equal to K, so we remove it from the stack. So whenever the count is equal to K, we remove from the stack. If not, if it's the same as the top of the stack, we increment. If not, we add a new one with the value of 1. Okay, so now we are here, right? We are here, and the value is B. The top of the stack is B, right? So we update it. Okay, because we removed this. These two got removed, just to be clear. Okay, and now we are at D. So we add D. Sorry, before adding D, this is equal to 3, so our K, so we remove it as well. Okay, so let's clean it up. Now we find a D, right? So now we are here, we find the D, so it's the top of the stack, so we update. So you can see, we remove this as well because K equal to 3. So you can see how, because these were collapsed, removed, and these were removed. So this, and this D got together now at the top of the stack, and so we remove them and pop them easily. And now what's remaining is we found another A, so we added value 1, and then we found another A, so we added here. And now we are done. We finished traversing the string, and now we just pop what's remaining in this stack, but we need to reconstruct it. So, which means basically we need to take each element of the stack and take the character and multiply it by the number of occurrence. Multiplying it basically by 2, for example, multiplying A by 2 means just 2 A's, and that's pretty much it, right? Now, what's the time complexity of this? So you can see when I was doing the traversal, I only traversed the string once, so it's O of n time, and we push and pop from the stack at most n times, and so overall it's O of n. So this is in terms of time complexity. In terms of space complexity, it's also O of n, because we are using a stack here that can contain at most n element. So O of n space complexity as well. Yeah, so that's pretty much it for the solution. Let's code it up and see if it passes the scale. Okay, so let's code the solution that we just saw in the overview. So the first thing is we need to initialize our stack. And then we need to have, we need to go through our string, right? And check if the top element is, so remember what we are adding is a tuple of the character and its occurrences, right? And so here we want to check if the top character is equal to the current one, then we do something, otherwise it's not. So when it's not, it's really easy, we just want to append the tuple for the character and 1, right? It occurred 1 time. But if it's similar to the one on the top of the stack, then we want to add 1 to the occurrence, right? And so what we want to do is to take the top of the stack, which in Python this is just the length of the stack minus 1, so n minus 1, but we can represent it like this. And what we want to do is just value 1, which is the occurrence, right? We want to add 1. Okay, so this would mean it will just end up, if we had C2, we'll end up with C3, right? And here you will notice I use the list instead of a tuple because updating a tuple like this won't work. Okay, so we add, and then we need to check if we reached k. Right? So we need to check if we reached k. We can also just do it here at the end, that's easier. So if we reached k, then we need to pop, right? Which means we need to just do stack pop. Okay? So if the top element has the same character, then we just increment it by 1. If not, we append a new pair with the character and the number of occurrences, which is 1. And then at the end here, what do we want to do? We want to return what's remaining in the stack. So let's say the stack has A2 and maybe K is equal to 3 and maybe has B3 as well, B2 or B1. So we want this to end up being 2 A's and B, right? So that's what we are going to do here. So we initialize a result to empty string, and then while our stack is not empty because we add everything to the stack, we get the count and get the character by popping from the stack, and then we do C multiplied by count. So this would be A multiplied by 2, which just end up being AA, and then we want to add the rest of res. You can notice here I'm not doing plus, I'm instead doing this so that the order is right, because the bottom one needs to be the first in the string, and then we can return res. And this should work, so let's try it. Okay, so looks good, let's submit. And it passes test cases. We can do a slight modifications here just to make this a little bit nicer. So we actually don't need to do this while loop. We can just use join, right? So we can just do this, join with the separator being just an empty string. And we can just we get the character, right? And then the count. And these are in the stack, right? And this will traverse it in the right order because it's a list at the end of the day, right? In Python here. Okay, so if we submit, it passes test cases. Cool. Okay, so another thing we can do is a trick to get rid of the need to check if the stack is not empty, and that can be just by adding here whatever string you want. Maybe we can just use $, but the number of occurrence is 0. This is so that when it gets multiplied by 0, it will be an empty string, and we get the same results as if we didn't have this. And that way we don't need to check, but we don't need to check if the stack is empty, but this check will fail for the first character, and so we will end up adding it. So it's just a nice trick to add a dummy value so that we can avoid checking for empty. So let's try that. Submit. And that passes as well. But both solutions in terms of time complexity are oven, space complexity oven as well, using a stack. Yeah, so that's pretty much it for this problem. Yeah, thanks for watching and see you on the next one. Bye.